Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the book Modern Physics by Paul A. Tipler. As usual, we first come to its statement. Okay, how fast must you be moving toward a red light wavelength lambda equal to 650 nanometer, nano meaning 10 raised to the power minus 9. Okay, how fast must you be moving toward a red light wavelength lambda equal to 650 nanometer for it to appear yellow wavelength lambda equal to 590 nanometer, green wavelength lambda equal to 525 nanometer, and blue wavelength lambda equal to 460 nanometer. Okay, so dear students, in other words, this problem can be split into three parts. Okay, not A, B, C, but it is our discretion whether we split them as part A, B, C or case 1, 2, 3. Okay, solution. First, dear students, we develop some foundation regarding the solution of this problem. Okay, so in order to develop our foundation, some snapshots have been chosen from some books. Okay, 1, 2, 3, 4, 5, 6 snapshots have been chosen. Okay, these snapshots will help us in understanding the problem. Okay, first snapshot, table 32.1. I do not remember from which book this snapshot has been selected. Okay, perhaps Resnick Holiday, Gerald Walker, or Raymond Survey John Jute. Okay, wavelengths of visible light. Okay, violet, blue, green, yellow, orange, red, and their range is given. Okay, from 380 to 450 nanometer violet, 450 to 496 nanometer blue, 490 and so on. Okay, we leave it. Similarly, the second snapshot, which may be termed as an alternate version of the same. Okay, approximate correspondence between wavelengths of visible light and color. Okay, wavelength range in nanometer and color description. Okay, violet, blue, green, yellow, orange, red. Okay, violet is from 400 to 430, while blue is from 430 to 485 and so on. Okay, last is red, which is 625 to 700. Okay, next there is a Doppler effect. Okay, Doppler effect, Doppler effect, Doppler effect. Doppler effect, electromagnetic waves source approaching observer. Okay, frequency measured by observer, f equal to under root c plus u over c minus u into f naught, where f naught is the frequency measured in rest frame of source and u is the speed of source relative to observer, c is the speed of light in vacuum. Okay, then alternate version of this snapshot. Okay, Doppler effect, source oblique observer approaching, source or observer oblique observer receding. Okay, in case of approaching, f is equal to 1 plus beta over 1 minus beta under root into f naught, while in case of receding, f is equal to 1 minus beta over 1 plus beta into f naught. Okay, the same snapshot is now split into two parts. Okay, that is f is equal to 1 minus beta square under root over 1 minus beta into f naught, which alternative becomes equal to 1 plus beta over 1 minus beta whole under root into f naught. This is approaching case. Okay, then f equal to 1 minus beta square over 1 plus beta f naught. This becomes equal to 1 minus beta under root over 1 minus beta over 1 plus beta whole under root into f naught. This is a receding case. Okay, so this snapshot has been split into separate parts. One is approaching case and the other is receding case. Okay, now next speed parameter has been described. Okay, if the relative speed between frames is v, the contracted length L and the proper length L naught are related by L equal to L naught 1 minus beta square equal to L naught over gamma, where beta is equal to V over C is the speed parameter and gamma is equal to 1 over 1 minus beta square is the Lorentz factor. Okay, now dear students, we have split this problem in three cases. Okay, case 1 is from red wavelength lambda equal to 650 nanometer to yellow wavelength lambda equal to 590 nanometer, nano meaning 10 raised to the power minus 9. Case 2, red wavelength lambda equal to 650 nanometer to green wavelength lambda equal to 525 nanometer. Case 3, red wavelength lambda equal to 650 nanometer to blue wavelength lambda equal to 460 nanometer. Okay, so we are going to part this problem in three separate cases, either ABC or case 1, case 2, case 3. Okay, case 1, using f over f naught equal to 1 plus beta over 1 plus beta under root over 1 minus beta under root. This implies that frequency is equal to C over wavelength lambda, so this will become C over lambda naught equal to right hand side is not disturbed. Okay, then left hand side will become lambda naught over lambda. Okay, because here factor in the lower part of the denominator will be shifted to upper part of the numerator. Okay, so it will become C over lambda into lambda naught over C, and hence C will be cancelled out with C and we will get lambda naught over lambda. Okay, this implies that lambda naught over lambda is equal to this. Now in next step, what we are going to do now, instead of lambda naught over lambda, we have found lambda over lambda naught. Then when we take reciprocal of this, then reciprocal of this will be alternatively taken. Okay, in other words, we can say that we shift this portion on other side of equality as well as we shift this portion on other side of equality. Okay, it will become lambda over lambda naught on right side of equation, and on left hand side it will become 1 minus beta under root over 1 plus beta under root. Okay, we can say both of these. Okay, either taking reciprocal on both sides or shifting both sides on other side of equality. Okay, so lambda over lambda naught is equal to 1 minus beta under root over 1 plus beta under root. Okay, now next we take square on both sides, then under root will be cancelled, and now in place of lambda we use 590 nanometer, and in place of lambda naught we use 650 nanometer. Okay, nanometer will be cancelled with nanometer and we will be left only with 590 divided by 650 square. So it will become equal to 0.82 equal to 1 minus beta over 1 plus beta. Okay, now we multiply 1 plus beta, we shift 1 plus beta on other side of equality. Okay, so it will become 0 plus 82 plus 0.82 beta minus. Okay, this has been the denominator has been multiplied with this, and then this figure is shifted on other side of equality, due to which it will become negative. Okay, this dividing factor will become as multiplying factor, while this factor will be shifted on other side equality and it will become as minus. Okay, it will become beta minus 1 on other side of equality. So it will become 0.82 plus 0.82 beta minus 1 plus beta equal to, this implies that minus 0.18 plus 1.82 beta equal to, this implies that beta is equal to 0.0989. Okay, our part A has been solved, our case 1 has been solved. Okay, now we come towards case 2. Case 2, lambda over lambda not equal to this, here we will use these two terms which are involved. Okay, so same procedure, no difference. Okay, here beta becomes equal to 0.21. Now we come towards third part, case 3, lambda over lambda naught 1 minus beta over this, here we will use these two values. Okay, then same, no change, exact same procedure. Okay, and hence here beta becomes equal to 0.33. Okay, and this is the end of our problem, this is the end of our video. Till next video, Allah Hafiz.